I wanted to make a, it's not exactly slides, but I wanted to do a video that will explain a little bit more of the material about consumer choice. And I realized that the slides and the book, that there was a little bit of, they didn't exactly align with each other given the assignment. So I thought it might be useful to at least have, it's not exactly a short discussion, but I'm hoping that this discussion can add to what the textbook provides. Okay, so the theme is consumer choice. So the question is how do consumers decide what they're going to purchase when they have multiple things that they could provide, so, or that they could consume? So for instance, how would I know that, right, 5 tacos, 3 bottles of Coke, and 2 bags of Skittles. I can describe to you right here. How would I know that if I gave you a certain budget, how would you know which of these to purchase, right? So the idea is that when you decide to buy something, there are 2 things that you are probably concerned about. And those 2 questions would be, do I actually want it, and can I afford it? And that's essentially what we're going to be dealing with here. This first question and then this second question. The do I want it question, we're going to talk about that with the indifference curve. And the can I afford it, that's going to be part of what's called the budget constraint. So we're going to deal with each of these 2 questions in turn. So let's talk about the first one. What I will do here is I will save these pieces of paper and I will scan them and I will post that along with this video. Okay, so here's my first question. Do I want it? So imagine a space. Imagine a space where I have, let's do my Skittles. Let's do a similar candy quantity of Sour Patch Kids. Also a great candy. Okay. So this is looking at only in terms of wanting it, not affording it. So the idea is that the quantities, so the Q stands for quantity in both of these cases, is that the quantities are going up. So if I were to put a point way out here, that would basically represent the combination of the 2. So we could imagine maybe this is at like 50 and maybe this is at 45. So that there's some bundle of goods, right? You could imagine kind of like a bag, a shopping bag full of these things. And in this shopping bag, there would be 50 Sour Patch and 45 Skittles. And as long as you're not a dentist or a health nut freak, you probably would really like that kind of thing. Maybe you wouldn't eat them all at once, but more candy would probably be, in terms of your preferences, that you're probably more likely to want more of both of them rather than some bundle over here where there are 7 Sour Patch and 5 Skittles. Making up the numbers here. Obviously they're following numeric order that we know, but I'm just making up these numbers here: 5, 45, 7, and 50. Just making them up. Okay, so if I were to present you these two alternatives, would you rather have 50 Sour Patch Kids and 45 Skittles, or 7 Sour Patch Kids and 5 Skittles? You probably would say, I want that more than I want that, right? Because this one has, let's be particular about why we would probably want this one, because it has more of both of the two products, right? There are more Sour Patch Kids and there are more Skittles. So it's pretty clear which you would prefer. Let's name these Bundle A and Bundle B. B would likely be preferred to A because you have more of both products. Now, what is it that you get from each thing, right? By consuming these things, you are getting something out of it, right? You're getting some enjoyment. That enjoyment is called, for an economist, utility. So essentially what we're saying is that by getting more of both goods, you would have more utility than you would having less of both of the goods. Now, by saying B is preferred to A, we're essentially saying the total utility with B is higher than the total utility that comes from bundle A. The A and the B, that's not standing for anything. It's just the letter A standing for this bundle of goods and the letter B standing for this bundle of goods. Okay, now let's put one in the center here, C. And let's put it directly in the center, even as the fact that we're dealing with a decimal now. Okay, so all I did here was I picked a middle point, calling it letter C. Now, what do we know here? We know that C would be preferred to A because C has more of both goods compared to A, right? C would be preferred to A. Same reason, because there'd be more of both of the goods. B would be preferred to C because B has more of both goods compared to C. So we know that these relationships exist so far, that B is preferred to A, C is preferred to A, and that B is preferred to C. And when we say that something is preferred, we are saying that it has more utility. But now here's the problem. And this is what's now going to give rise to the indifference curve. What about a point right here? So in letter D, I'm going to kind of make up these numbers here. But let's say that it has 50 Sour Patch and 15 Skittles. Again, making up the numbers here, but not really. So in letter D, I have more of one good, but I have less of the other. Let me repeat that again. If I were to compare bundle C to bundle D, I have more of one good. I have more Sour Patch Kids. But I have less of the other good. And I could imagine writing another one out here. In bundle E, maybe I have 10 Sour Patch and 50 Skittles. What's the relationship between C and E? Right? I have less of one good and more of the other. The question is whether here's the issue. We know that a relationship exists between C and D. And we know that a relationship exists between C and E. And there's a possibility of one of three relationships. That the possible relationships are preferred. That would be one where there's higher total utility. The bundles could be not preferred. Some bundle could be not preferred. And I would say that it has lower total utility. Or you could be indifferent, meaning that the same total utility exists. So indifference basically means, I don't care. Like, I like each of them equally. Like, if you were to ask me, Scheiding, do you like cheese pizza or pepperoni? I'm actually largely indifferent. I get the exact same amount of satisfaction. My wife, on the other hand, really, really loves pepperoni pizza. And, right? So for her, she has a strict preference for pepperoni. When it comes to Hawaiian pizza, I don't really like pineapple on my pizza. I'm not, I'm from the mainland originally. It's not my style. But my wife, she's had that pizza forever, so she's grown to like that kind of pizza. So, for her, there's a preference. For me, no preference at all. Well, actually, not no preference. I have a negative preference. In other words, I don't like it. Any of these bundles have to have one of these three relationships. So when I put these all on the same page here, you can see what the relationship is between B and C. B is preferred to C. We know that because you're getting more of both goods, so the utility must be higher. C is preferred to A. Why? Because it has more of both goods, so it must clearly be higher. But again, the relationship between C and D and C and E is less clear. You need a little bit more information. The piece of information that I need to be able to talk about the relationship between C and D and C and E is I need to know my marginal utility. The marginal utility would be my change in total utility over my change in, for instance, the quantity of Skittles. And what that would equal is the marginal utility of Skittles. And I could do it for the other product as well. Change in total utility over change in quantity of Sour Patch Kids. And that would equal my marginal utility of Sour Patch Kids. So, what we need to know, right, is that as I'm changing this quantity, the quantity could be going up or down. The question is how much additional happiness do I gain or lose by getting more Skittles or fewer Skittles, or more Sour Patch Kids, or more or fewer? Let's go back to this. Let's try to keep this all on the same page here. So what we're trying to say here is I can see that going from C to D, I'm gaining 25 Sour Patch, but I'm losing 7.5 Skittles. So the question's going to be, right, if we're looking at the marginal utility, is by gaining 25 Sour Patches, how much should my utility go up? And is that enough to offset the loss in utility that came from having fewer Skittles? What we can draw out here at this point is what's called the indifference curve. Some curve, let's try to write this out here like this. That the indifference curve would trace out all the combinations of the goods where the total utility is constant. Or where if the total utility is constant, that's where you basically say, I don't care, I'm indifferent. That's the precise meaning of indifference, is that your total utility is constant. That you are equally happy having one combination versus the other. If I recreate the exact same picture that I had, let's see here. Here is where my bundle C was, my D, and my E. That with a little bit more information, I could draw out a line where the total utility is constant. So by putting a bar over it, I'm basically saying it's constant. So this would be saying that my utility is constant along this picture, along this line. And that all combinations of the goods that are on this line have the same total utility. Let's just write a number here. The total utility equals 100. I'm making up the 100 number. There's no mathematical knowledge at this point that you would know that it's 100, but let's just say that it's 100. Now, I can see that D, point D, is a little bit to the right of this. This space is filled with a finitely large number of indifference curves, meaning that there's another indifference curve that's exactly parallel to this one, where let's say the utility is equal to 110. There's another one, let's say right here, where utility is some bigger number. Some utility here, some smaller number. But we would also imagine, and I'm going to draw this with a slightly different color here, but that this space is just filled with a finitely large number of points. covering that entire space. And what we see is that higher indifference curves are preferred to lower. By me giving you some additional mathematical information, what we can see is that the consumer is indifferent between C and E, that they are indifferent. They are indifferent because they are along the same indifference curve. But, based on this, that the consumer prefers D to C. Let's go back to what we saw over here. Before I added that information, you had no way, with the information you had here, you had no way to compare C or D or C and E. There wasn't any certainty because you had more of one good but less of the other. More of one good but less of the other. But we knew that one of three relationships existed. Either they were preferred, not preferred, or indifferent. The additional piece of information I'd have to provide is some knowledge about how much additional happiness you get from consuming a product. How much is my total happiness changed by when I get more or fewer Skittles? How much additional happiness do I get when I get more or fewer Sour Patch Kids? The triangles, just in case you're unfamiliar with that, that stands for the change. The change in total utility over the change in Skittles. Change in total utility over the change in Sour Patch Kids. Basically, then, the additional piece of information I would have given you is saying the trade-off between the two, there was enough of a gain in the Skittles to exactly offset fewer Sour Patch Kids. But here, for D, I got more utility from Sour Patch Kids, and it overwhelmed, was much greater than my loss in utility that came from having fewer Skittles. So, let's talk about the shape of this curve. The slope of the indifference curve is known as the marginal rate of substitution. Basically, what is my willingness to substitute one good for the other? And what that's equal to in this case is it's equal to, so the slope of the indifference curve is called, the technical name for it is the marginal rate of substitution. And what the marginal rate of substitution represents is the ratio of, now it's negative because it's downward sloping, so it's always negative, but it's equal to how much my utility changes when I get more Skittles, or in general what's on the x-axis, over the marginal utility, how much my utility changes by when I get more Sour Patch Kids. So the marginal rate of substitution is equal to the ratio of these marginals. Now, one thing that we see as we conclude this discussion here is that there is a diminishing marginal utility. And this diminishing marginal utility is the fact that additional satisfaction from an additional product eventually falls. So this is my own definition of it. The book and certainly the internet have slightly different definitions of this. But what we're saying here is that for any product, here, let me give you an example here. This is what I'm eating right now, almonds. Almonds are pretty great. It's 2.5 pounds. I think I bought this like 3 weeks ago. About 3 weeks ago. 2 or 3 weeks ago. Well, what if I tried to eat all of them at once? Right? What if I just sat down and said, I want to eat 2.5 pounds of almonds right now? I almost could guarantee you that, right, the first almond is pretty great. Almonds do taste pretty great. But maybe by like the 50th almond, I'm like, oh my God, why did I ever try to start doing this? Now, it's not that I'm like throwing up or like, or anything bad's happening yet. It's just that the additional happiness that I get from an additional almond is not as high as what I got from eating the second almond compared to the first almond. Right? Because like when you consume anything in the very beginning, each additional item gives you like a really high amount of happiness. And I'm not saying that I'm not still happy by eating the 50th almond. Let me repeat that again. I am not saying that I'm not becoming happier by eating the 50th almond. What this is saying is that the additional happiness that I get from consuming the 50th almond is not as high as the additional happiness as I got from eating the second almond. That's what this says. Let me repeat that again. What this is saying is that the additional happiness that I got from eating the 50th almond is not as high, not as great, as the additional happiness as I got from eating the second almond. That eventually you get tired of eating something. Okay, let's now deal with question number 2. Can I afford it? Now what I'm going to do here is describe this, and then I'm going to bring it all together with step 3. And in step 3, so it goes beyond these 2 questions here, we're then actually going to talk about what the consumer ultimately will decide. Whether a person can afford it or not depends on their budget constraint. And what the budget constraint has are 3 elements. It has a person's income, the price of good 1, and the price of good 2. We assume that all income is spent. So, let's write this out again. quantity of Skittles and quantity of Sour Patch Kids. Okay, so far I've got nothing different than what I had with my earlier space, right? It's the same kind of axes labels. Well, the idea is that if my income was $100, and that the price of Skittles, let's call that P subscript S, the price of Skittles was $2, and that the price of Sour Patch Kids, let's call it SPK, the price of Sour Patch Kids was $5. Obviously, I'm making up these numbers. Skittles cost $2.33 if you buy them this week from Target. Sour Patch Kids, I don't know how much they cost. I'm not a big Sour Patch Kids friend. The idea is that let's first start with what the x-intercept and the y-intercept would be, meaning where does the line cross these two axes. So how many Skittles could I buy if I spent all of my income on Skittles? That would be $100 divided by 2, right? Because I would be basically saying if I have $100 and each one of them are $2, I could buy a maximum of 50 Skittles. That's going to be my one axis. Now, what if I spent all of my money on Sour Patch Kids? Meaning $100 divided by $5. Now, the most Skittles or Sour Patch Kids I could buy would be 20. That's going to be my intercept here. And then all I do is connect the dots, where the slope is equal to the price ratio, which in this case is going to equal the price of the good on the x-axis over the price of the good on the y-axis. Because here, the trade-off is not saying like how much additional happiness I get from one or the other. It's actually a very technical thing. If I buy Sour Patch Kids, that means 2.5 fewer Skittles that I could buy, right? Because $5 represents one Sour Patch Kids, or it represents 2.5 Skittles. Assuming that we could divide goods up. I can't spend more than my income. This would presume that my income is higher than it actually is. If I were below this budget constraint line, this is called our budget constraint line. If I was below this budget constraint line, the problem here is that I'm not spending all of my income. And I want to spend all of my income. Now, let's take this understanding and slightly manipulate things. Let's look at a first scenario. Let's call it possibility number 1. What if my income goes up? Well, if my income goes up, what happens is that I'm just kind of keeping this, just kind of writing this quickly here. Here is my original budget constraint line, which we already determined, 50 and 20. But what if my income is now double, is now $200? Well, then what that would mean is that this will now be 200 divided by 2, which is going to equal 100. And that this over here is going to be 200 divided by 5, which is going to equal 40. So I would have 100, and I would have 40. And what we see is that if my income goes up, my budget constraint shifts out compared to what it used to be. What if, for possibility number 2, what if the Skittles price goes to $5? Here is my original budget constraint, and again it was at 50 and 20. So here what we're saying here is that the income is back to 100. Price of Skittles is now $5. Price of Sour Patch Kids is now $5. Over here, we were saying that the income, just to remind you, was 200. Price of Skittles was $2. Price of Sour Patch Kids was $5. And then again, the math I'm using here is that I'm taking my total income and dividing it by the price of the product. So now what we're seeing for Skittles is that it's 100 divided by 5, which is equal to 20. And that over here, it's 100 divided by 5. This 5 is referring to here. This 5 is referring to here. So now it's 2020. The line basically becomes steeper. What if the price of Skittles had fallen? I'm just going to keep this. Obviously, this is kind of like possibility 3, but we're just kind of saying, what if the price of the good on the x-axis changes? What if it had been $1? Then it would get flatter. And then for possibility number 3, what if my Sour Patch Kids goes up in price to $10? Draw it out again. So my income is still 100. Price of Skittles is back down to its $2 price. Price of my Sour Patch Kids is now $10. It was originally at, going back to our math here, was originally at 50 and 20. Originally it was at 50 and 20 because, right, the old price of Skittles was $2, which it still is. The old price of Sour Patch Kids was $5, but now it's $10. So that would mean 100 divided by 10 is equal to 10. See what happens here? See the commonality of what happens here? This is not changing because I didn't change any of the elements of the income or the price of Skittles. But it pivots and now becomes more expensive. Just as over here, you saw the pivoting, but from a different perspective. Whereas none of the elements here were changing, it's just that my x-intercept was changing. What if instead the Sour Patch Kids became $1? then it would fall to 100, or I'm sorry, increase to 100. And now you would see that shifting out. So how do we put this all together? Which is now the final step to this. Is that we start out with the picture that we originally had here. Sour Patch Kids and Skittles. I'm going to go back to the original things I had here. Here was my point A. Here was my point D. Here was my point C. Here was my E. And here was my B. Well, the idea is, right, I drew a line here, and in this case I had a line that was like this, right? It was kind of going through E, and we said that there were, multiple lines here. Right, we can imagine multiple lines existing here. And these are my indifference curves. And now what we add to this is a budget constraint. And in the budget constraint, just looking for a different color here. In the budget constraint, that we could draw out, we see this kind of straight line. So I'm hoping you can kind of see the colors here. If not, my apologies. This right here, again, is my budget constraint. These three curved lines are indifference curves. So what's the problem with A? The problem with A is that it's below the budget constraint, meaning I'm not spending all my money. So A is not going to be a good point, because I would have money left over. And we're assuming, again, that we're spending all of our money. So A lies below the budget constraint. What about B? B, you can't afford it. It is beyond the indifference curve. I'm sorry, I take that back. B is beyond the budget constraint. Yeah, you'd want it. Of course you would want B. But you can't afford it. And we all have experienced that with certain things that we really, really want, right? There are some things that we really, really want, but we cannot afford it. There are other things that we could buy that we don't necessarily buy because we'd have a lot of money left over. We can get better things, right? Because there is an indifference curve going through this, and you'd be kind of happy, but you could be so much more happy. D lies beyond that budget constraint, as does E. But look at what's happening with C. At C, not only do I want it, but I can also afford it. At point C, not only do I want it, but I can also afford it. Which now gives rise then to the goal. And the last thing that I'll say for this lecture. The goal is that you're trying to get the highest indifference curve that touches the budget constraint. Has to touch it because I am just going to spend all the money that I have. Can't spend more than I have. I don't want any money left over. But I want the highest indifference curve that touches the budget constraint. See the problem with this blue line here? Let's add another point here. D, E, F. Right? And let's add another one here. G. If we look at F, the problem with F is that I'd have money left over. But what about G? In G, I wouldn't have any money left over. I would be spending all of my money. But the problem with G is that I could be happier. The problem with G is that I could be happier. I could be on a higher indifference curve. Higher meaning to the right, which gives us that goal then. How a person decides how many Skittles to buy versus Sour Patch Kids reflects a person trying to be as happy as they can possibly be while spending all their income. Okay, so I hope that helps to understand how consumers make choice, and I hope that that helps you take care of the homework assignment.